I just want to take you back to what is now a very topical debate. In fact, and for me, climate has always been a mystery. So I'm today going to share with you, convey to you is how little we know. So for me, climate is an enigma, it's a mystery. And why it has become so important for us to revisit this whole notion of what we understand climate to be is because of the hysteria that has come to surround this whole debate of climate change. And then it also has grave ramifications, and we need to look at what it actually portends for all of humanity. So this study has been done at IIT Delhi. Vilakshana and Arvind Baiwa are the research scholars who have done the study in a big way. They are not working on these topics. Vilakshana is working on geomorphology and Arvind is working on phase transitions. And of course, our own Dr. R. Maheshwaran. So he is my shield in case you have any questions later after I leave. You can always have a confusion here. So I am trying to present to you the alternate reality as I see it. Now, the common perception that we have about climate change is being triggered by the greenhouse gas emissions and principally the carbon dioxide emissions. And this is on the basis of what we have observed to be increasing trends in global temperatures, and there could be some more indicators. And in this blame game, we blame the socio-economic aspirations of humans, and we believe that the post-industrialization period, when we moved to a more consumption-oriented society, that's what perhaps may have triggered what we now say is climate change. And in addition to the standard of living we believe is responsible, our reliance on fossil fuels. These two are seen to be the principal villains in this whole game. And what we see happening is not just in terms of climate and what seems to be happening with it, but also what seems to be happening at the social levels. So it's actually seeing mobilization, ideological mobilization, socio-economic mobilization at scales which is unprecedented. And there's a new dimension coming into this because our young minds who are still in schools, they come overloaded with this feedback from their teachers that we are doing something terribly wrong with our system, with our earth, and they come with a lot of guilt, they come with a lot of fear when they return from schools. And I have seen some of the course material the small children are exposed to. It is not difficult to understand why there's so much of fear that's logically going to actually manifest in our young minds. And in all this, much like what happened with the Diwali cracker issue, there's a new kind of morality here also that is taking place. So where does the government come in now? The government is looking at policies, they are debating policies, they are tweaking policies, they are redesigning policies, and this is all on the basis of the skewed aspirational paradigm that we have come to blame it for. And these also entail, in case we plan changes in our policies, in our mindsets, in our outlooks, it's also going to come with a lot of burden on resources, because it talks about a change in the way we have actually set aside resources for various things that we did. So what are we heading towards? So we are heading towards a campaign which is going to result in lifestyle changes, reapportionment of public investments, planning paradigms are changing, and especially for a person sitting in academic institutions, there is a reorientation in research focus. And what has been my observation, because IITs are always in the recruiting mode, we have candidates who apply for faculty positions, and every year we have people getting recruited. And especially in the field of water resources, much of their work is actually on this business of climate change. And it's not something that's happening in India, because most of our candidates who are applying for faculty positions, they are coming from abroad. And that's a very serious concern. And in fact, there was a candidate who had applied for a professor's position. He has almost about 75 publications. This is a guy from Malaysia, remember? So we asked him a simple question on Manning's equation. Now, Manning's equation is the first thing that you would use when you studied open channel flow. And he had absolutely no clue. Because much of his work was dominated by climate change models and what they did, what kind of results they derived, and there was a total disconnect with the reality. Now, an engineer who is applying for a faculty position is actually disconnected with the engineering reality of the system, but is actually working this esoteric domain of climate change, the benefits of which we are not really sure of and when they are going to be realized. So what is this pursuit all about? And the result is much of the research that emanates from these endeavors is mundane, mediocre, misdirected, meaningless, but unfortunately it comes with the assurance that publications would be easy to get. And this is a lure that is driving a lot of people towards this kind of research. And I have an example, a paper that was sent to AGU, where we try to present an alternate reality, was not accepted. And Vilakshana, who was there the first, she was there in Minnesota, and she was in touch with the president of the hydrology chapter of AGU. And when she told her that it was something that we don't believe in, she did not challenge. I mean, this lady she's a big person in the field of hydrology, and she's a very well-known person in American Geophysical Union. She told her there is some immorality in the way you are denying this. So you are not actually challenging a person on the basis of scientific content in the work that you are presenting. Since you are not accepting what is commonly held as the majoritarian point of view, if you show a little bit of a dissent, you are characterized as being immoral. And that was the term that was used. So this is the danger that we are actually facing today. And lastly, much of this research, and I can assure you, those of you who are planning to do something on climate change and the way it is being handled, I can assure you, even if you have publications coming in by the dozen, they are not going to have much shelf life. They are going to be forgotten the moment they appear in print. So it's not something either you are going to be proud of, or people are not even going to remember that such a work has been done, because it will have absolutely no value, no relevance. Then, of course, there are profound economic and national security ramifications of what we are actually trying to do. Now, in all this, who is this divine oracle? Who is telling us what's likely to happen? The so-called global climate models, and I have underlined this because I have come to this later towards the end of my presentation. And there are almost about 24 of these so-called climate models. Then models are not divine entities, they are being made by people like you and I. So it's the kind of logic that I build in here that determines what kind of responses you are going to get. The algorithms are designed by people like you and I. So the people who design these divinely gifted wonder machines, and what are they capable of doing? They are capable of telling us what's going to happen 100 years from now. And we have the outputs which are being given out, and they are being used as blindly. They tell us on a daily basis what is going to be the precipitation that you are going to expect for the next 100 years or even longer. And it's not just the precipitation that they say is going to be like this for the next 100 years on a daily basis. You also have information coming to you that says these are going to be the temperatures and also cloud covers. Now, what can be more ridiculous than this? It means 100 years from now, to precisely the day, you can decide whether on that day you need an umbrella or you don't need an umbrella. And what can we do with our weather? We are not capable of predicting, forecasting is the term, weather beyond 3 days. 5 days, weather forecast coming out right is a miracle. So here on the one side, we are saying that we have the capability of forecasting weather for the next 3 days, but miraculously, these models give us temperature, rainfall, cloud cover, and blah, blah, blah for the next 100 years. So the question that I have is, isn't it possible that they could have got it all wrong? We don't understand the term climate. What exactly does it mean? The climate models that they fabricate actually are not climate models at all. And these actually represent very gross and inadequate reality that we belong to, we are a part of. And yet these are things that they are relying excessively, coming out, churning out data from data to data, and which are in a very foolish manner, because we are so gullible, we are using it, trying to tell people what's going to happen with the hydrological system, and then putting pressure on the government, telling them that this is likely to happen, please change your policies, please have investments in this area, and all based on something that I cannot even vouch for. So what are the policy ramifications? Are we being deliberately pushing ourselves towards a newer and a graver challenge? And it's, in my view, something like a self-goal that we are scoring. And obviously, as a result of this, I want to share my apprehension with you, because I sense that there is some suspicion that it arouses. Now, before I start formally the presentation, let me make it very clear. I'm not a climate expert. I'm not even a climatologist. I will call myself one. I'm not a climate change expert, but then my view is that who is? I have only questions, I have no answers. The problem is, I cannot even define the term climate. I don't even know. If you ask me how do you define climate, I have to scratch my head and say, I'm sorry. Because if I need to define climate for you, I have got to be arbitrary. And it's not just being arbitrary. I have to be subjectively arbitrary. I have to be subjective, then decide what kind of an arbitrary judgment I have to use in order to give you a definition for climate. Which, as a scientist, if I have to be a morally upright scientist, I should refuse to do.
Now the question is, in all this, where exactly is the mystery? Where exactly is that proverbial rat hiding? Is it because we have not been discerning enough to understand the difference between climate change and climate variability? What we see as climate change, could it be an innate variability in climate? And because climate is a phenomenon, it's a notion, that's why I can't define it. It happens over so many years, and if there is a certain sense that is prevailing over that period, we see that as a secular trend. And if we ignore these differences, then are there any dangers that are lurking ahead? So the whole idea is we need to look at this particular issue. Is there a difference between climate change and climate variability? And is that something that we need to resolve before we jump onto the bandwagon? Now, if I look at observable climate signals, I have a time series. Now, are these signals a mix of unstructured and random noise? Or are these the curious mix of well-defined patterns? And these patterns would have possibly causal linkages with some having known physical phenomena causing these patterns, and some even hitherto what I don't know. And all these linkages are operating perhaps at various scales. And the issue is, what kind of multi-scale phenomena do I have? Is there an underlying scale invariance or scale-limited scale invariance? In other words, what kind of a multi-scale phenomena is at work? This is something that I need to look at in order to understand what kind of variability do I see in what I don't know how to define. And if I am able to study these patterns, then the question is, do these patterns go beyond the restricted domain of influence that we have come to attribute to the anthropogenic carbon dioxide footprint? The question is it enough for carbon dioxide to give you the kind of patterns that I see in a typical phenomenon called climate? So that's my presentation today. We are going to look at one aspect of the overall notion of climate. And this is an ongoing study. Metaphorically also, it's still a work in progress because there's a whole lot more that I am going to be raising my hands up for, not in a position to explain. So what we have used is a record of temperature. It's a reconstructed record of temperatures, and these were derived based on the ice cores, North Arctic ice cores. And each value in that record has a sampling interval of about 100 years, and we have a total of 3 million year data. That means we have temperatures going from the present, which is for us 1950 by the way, going back from 1950, 3 million years. So I'm going to present to you the temperature record. That's not my creation, but we have analyzed this, and it goes back 3 million years, and this is what we are going to study, and this we are using as proxy for paleoclimate. This is that plot. This is the plot of the temperature record for the past 3 million years, and you can see that it goes up. But where are we? Here or there? 3 billion years ago, we are here. It's a wonder of wonders. We were in a much more warmer place 3 million years ago than we happen to be now. And this trend is not the only thing that is a matter of concern. It's an increasing trend going back. So coming from back to front, it's a decreasing trend. But please note, what is the range of variability? This is almost about 20 Celsius degrees. So 20 Celsius degrees is the range of variation in the temperatures that have actually happened, that have been observed. And we were not burning fossil fuels at that time. There were no cars. There were no smokestacks bellowing out smoke. So how do you explain such huge variation? And what are we worried about? We are talking about a climate change scenario where they say end of the century temperature is going to be up by almost 2 Celsius. The natural variability in this particular series seems to suggest that temperatures have fluctuated for almost about 19 Celsius degrees for apparently no reason. So we have trend, we have the variability, and there is something very important now. There is a hint of some kind of cycle being repeated. And if I look at this snapshot here, this is what I get. We have well-defined cycles in our temperature record. And all for no reason, apparently. And as a first, we just plotted the autocorrelation function. And what do you see? You see cycles within cycles within cycles. So there is somebody there who is controlling the temperature record as an expression or as a reflection of climate in such a precise way, where precise is, it is in quotes. It doesn't necessarily translate into predictability. But its patterns are discerned. There are cycles within cycles as is seen from this autocorrelation function. Now let's go back to another snapshot. These are the intervening cold periods between warm periods. And our global temperatures have actually fluctuated in the manner shown. So the lows correspond to the glacial periods, and these are all interglacial, and this is the period when the Earth would have been warm. Now let's focus on the last 26,000 years. This is the temperature record 26,000 years ago, and this is our present. So this is the last glacial maximum. This is the coldest. And you can see the temperature rising, and the ice started retreating about 18 to 16,000 years in a slow recession. From here, it was a relatively rapid rate of recession, and then reglaciation happened around 8,500 years ago, and then again recession 7 to 6,000 years ago. This is happening. So pattern of ice cover changes, last glacial maximum here, ice recession started by about 16,000 before present, initially slow recession, followed by a rapid recession later. And this is the era when the ice started retreating. This is known as the pre-Clovis era. And this is the time when migration of humans happened or started in the North American continent. This became possible only when ice started retreating. And that's what is worrying us today. Why? Because we believe that it is because I am driving my car. But this phenomenon of recession of the ice sheet happened almost about 16,000 years when humans were able to migrate down the westward and down to the South American continent. And then we had, again, the reglaciation and followed by, again, recession. So, a little bit of mathematical analysis. This is the periodogram, and in this periodogram you can see two ranges of cycles from 20,000, 40,000 years, and there is one having a period of about 100,000 years. And this range of cycles from 20,000 years to 100,000 years, it is able to explain 54% of the variability that is seen in my temperature record. And what does that mean? I can throw away the entire information if I retain information only about these three cycles. 54% of the variance is explained just by three of these. And further, the 100,000 year cycle explains about 21.8%. The 40,000 year cycle explains about 25%, or rather 26% close approximate lag, and the 20,000 year cycle about 6%. So there is something more profoundly dynamic that is happening, and that describes what is happening in our climate. And we are not even bringing in carbon dioxide as a factor due to anthropogenic use. And this is the wavelength spectrum. Now, wavelength spectrum, quite unlike Fourier-based spectrum, gives us not just the principal harmonics, but it's also going to tell you when during that time period was a particular harmonic very effective and where was it minimally effective. And this scale on the right-hand side gives us the intensity, the power that is contributed by these three. The three that I'm talking about is the 100,000 year marked in yellow, black dots. The 20,000, 40,000, and this is the 20,000. So intensity in the color tells us what is the strength. Now what do I see? There is this large area. This is 3 million years, about 1.5 million years ago on either side. This 100,000 year cycle was very weak. And here it seems to have been very, very strong. But it's unmistakable, the dominance of these three cycles. So the question is, if this is a pattern, what is responsible for these patterns? Now before that, this was the original series, and these three, the 100,000 year cycle, the 40,000 year cycle, and 20,000 year cycle, we removed those cycles from this record, And what do I get? A series which doesn't apparently have any structure at all. So it's much more like random white noise. I wouldn't call it white noise, but random. Because I have removed the three main cycles from this data. But even in this, please note, while apparently it is missing the influence of these three cycles, there is still the variability that strikes us. And this variability, for apparently no reason, can make the temperatures fluctuate by the order of almost about 7 Celsius degrees. So the range of variability, which does not seem to have any underlying cause, we need to come up with a credible explanation for this. If we need to understand what's climate for us, and then study what's happening in the recent times, what we say is climate change. So there are 7 scales which have been plotted, and you can see some of us who are working in the area of structural dynamics would recognize this feature as the beat phenomenon. So there is something innately remarkable about this temperature record as a proxy for climate. So all the 15 scales have been plotted. This green line is the actual record. Now please note this cycle here, which has a period of about 100,000 years, how remarkably it is able to tell you when you are going to be having a low. So what it tells me is that as far as the lows are concerned, if I am able to get a handle on this 100,000 year cycle, I know pretty much when my glaciation periods are going to occur. But of course it is a little out of sync with the peak values, because there are other cycles which are also interesting, and these seem to be dominating over this cycle as far as the definition of the larger values is concerned. So you can clearly see that there is a multi-scale phenomenology, and these possibly are linked to different processes that work at these corresponding scales. So the three dominant 100,000 years, 40,000 years, and 20,000 years. So what governs the actual trajectory? Is there a chaos-like behavior? Now, chaos is an attribute of a class of nonlinear dynamical systems, where the systems show very high degree of dependence on initial conditions. We'll come to that later. And just these three cycles plotted against the actual data, and you can see that they are doing a very good job at explaining the variability in the temperatures. Now if I take a closer look at this, you can see how nicely it's able to explain the variability in the temperatures. Just these three cycles. Now what are these cycles about? These pertain to the Earth's orbital parameters. The 100,000 year cycle is on account of eccentricity in our orbit. The 40,000 is on account of obliquity. And the 20,000 year cycle is on account of precession. And they are all called Milankovitch cycles. But you can now see that these three cycles have a dominating influence as far as our climate, at least as far as our temperature records are concerned. Do these figure in our climate models? No. So that means the 50% at that scale of variability that happens to be there in our temperature record is actually being managed because we have tweaked our climate models to overcome the deficiency, because this does not get reflected, but somehow because we adjust the parameters to obtain those kind of behavioral patterns, so that we can actually justify so much of money being spent on these initiatives. So there is some element of mischief here. If my climate model does not capture this fact, how can they say that their climate models are working remarkably well? So what exactly is it that they have done with their climate models that is able to generate the kind of patterns we have observed? I have no idea. That's why I'm concerned. And I want to share these concerns with you so that we can go back and revisit, because all this data is there on public platforms. I mean, Dr. Maheshwaran will tell you where exactly you can download these, you can carry out independent analysis. So we need to acknowledge that climate is just a notion. It's a notional state and is a manifestation of an integrated complex of a mix of various dynamic phenomena. And importantly, climate does not possess static attributes for which you could define an average. So, can there be such a thing as an average descriptor for a climate? No. Even if I were to average it, then over what time period do I need to average it? And who decides? Is there a principle involved here? If I take a statistical explanation for the word average, we know how to define that. But it means the entire length of time. So is climate amenable to a consistent description? That is, does Earth's weather have a long-term average? Often the answer assumed is in the affirmative, because it appears to be rational to believe that a measurable behavior, no matter how it fluctuates, must have an average. That's the fundamental flaw in our understanding. And nothing can be farther from true. So some events that have happened in history, I'll just quickly explain to you. This is the temperature history that we have plotted for the last 26,000 years. This was the time when we had the maximum glacial cover. This is the time when the Great Barrier Reef started forming. At that time, it was above the surface of the sea. Because of the melting, when the ice started retreating, the ice started melting, the sea levels rose. And this Great Barrier Reef, which was above ground, became submerged, as we see today, around this time. So the sea levels have always been rising. Then formation of British Isles. It was connected to the continent of Europe. There was a land bridge connecting that to the Irish island. That got submerged. So Great Britain is an island now. Formation of the Strait of Bosporus can be linked to that. Our own submergence of the city of Dwarka. Then the decline of the Harappan civilization. It's also believed to have happened about 7,000, 6,000, 8,000 years ago on account of climate change. But then climate change on account of what? Because we were not burning fossil fuels at that time. So 6,000 years ago, the Great Barrier Reef became a submarine system. But before that, about 15 to 20,000 years ago, the sea levels were lowered by about 100 meters than where they are now. And in the past, they've also been 9 meters above than where they are now. So this phenomenon of sea level change is not something that's happened or started happening only recently. So these are some visuals of Dwarka. This is the Harappan civilization, and here we can see that there is an intensification of monsoons, and then recession, weakening of monsoons here. And you can see the time when it happened. This is before present. And now this seems quite credible, because if the sea levels were lower by about 100 meters, then Ram Setu perhaps was something that was quite credible for these people to have built, because the kind of waterway that needed to be negotiated was very small. And this is a recent Google image. You can do that yourself. You can clearly see the connection. In between you have these channels, but this is how it is. Rameshwaram is here. This is off the coast of Alexandria in Mediterranean. Civilization that's underwater now. There was an intense acidification that happened 4,200 years ago, and it's called the 4.2K acidification event, and it's regarded as the most severe climate change that has ever been experienced, and it's believed Sahara, Thar Desert, and all these things happened around that time. Then the Old Kingdom in Egypt, the collapse of the Liang culture in Lower Yangtze River Basin in China. And of course, strangely, there was also something that happened. There was a cooling that happened near North American continent. It's called the Bond event, which initially they thought had a 1,500-year periodicity. Now we have only a 1,000-year periodicity. So that means there is something more than these three cycles that contribute to what we believe is happening with climate. You can see this is evidence of soil being present here, and ancient soils were preserved in the basal ice for millions of years, and the sediment that's extracted is found to be old and mineral rich till it got covered by ice. So that means it was not all there at the time. Now in all this, what is the role of the sun and where is the sun? Now it's also seen that the sunspot activity that we've seen in the last 70 years has been amongst the most intense, of the same order of intensity as happened during the aridification. So perhaps what we are observing today may be on account of solar activity, which is happening at a more intense level than it has ever been. And this is the temperature record over central England, starting from about 1659. And you can see the 30-year average that I have plotted. This is in red because people deal with these 30-year average as a definition for our climate. So I have used the same argument, and you can see how it happened then. And you can see that it was falling, it went up for about 30, 40 years, then almost about 60 years it was rather constant for no reason, till it started going up, going down for a length of time, and then this is the present. You can see the clearly increasing trend. And if you look at the power laws, there are clearly three distinct regions. I have shown only two here. In the previous one, we had three. And it's this segment that corresponds to the three cycles that we attribute to the global parameter, the Earth orbital parameters. And what's interesting, when I look at the phase space plot, this is for Gaussian noise. You can see agonicity staring at you. This is the data set. Not at all. There is something very strange. And when I plotted the phase space plots at intervals, this is 5,000 years, you can see the classic donut shape, the toroid. And you can refer to this paper by Lawrence. This was in 1963. And he was the first one to have tried to build a climate model.
or rather a forecasting model for climate, but then discovered when he looked at just, it was a set of 12 equations, 28 and 12, and what he did then separately was use only the convective part. These are 3 equations, and when you work with this, it is an accident, it's documented in literature, I suggest you read that, this classic, what's called the strange attractor. And we have this kind of phenomenon seen in the earlier slides also, the strange attractor in the form of a donut. So there seems to be some element of chaos there, which means that whatever we seek to do is beyond the domain of predictability. And what he observed, chaos ensued and averages were seen to fluctuate widely, a classic example of non-ergodic behavior. This paper is in 1968, and here he described transitive systems, intransitive systems, and almost intransitive systems. And the important thing is the possibility that long-term climate change may result from the almost intransitivity of the atmosphere rather than environmental changes, and whose statistics taken over very long but finite intervals differ considerably from one such interval to another. So these systems show one kind of behavior over a very long time. A completely different kind of behavior could be just as natural for that system. And these systems can stay in one equilibrium or the other, but not both. That is, climate may possess several distinct regions of utterly different behavior. And one climate that so mysteriously changed to a different climate for no apparent reason. The question then can be posed, is it possible that a system like the weather may never converge to an average? And climate modelers know this, but ignore it at all costs because they know that it becomes too unpredictable. Because they are committed to telling us that whatever changes we are seeing are happening because of carbon dioxide due to anthropogenic reasons. So almost intransitivity could be the reason why our planet in the past has drifted in and out of ice ages, which in turn may be the result of chaotic dynamics. And it's a well-known attribute of classical non-linear dynamical systems. So the question is now, what is climate and what is our understanding of it? Do the noisiest amongst us know enough? And who is leading this debate as against who should? Is the study of climate all about mere scrutiny of atmospheric circulations? And why the notion that climate is essentially not meant to undergo change? Where did this notion come in from? And whose imaginative minds are at work here and seriously are being brainwashed? And then in order to quantify change, do we not need an objective benchmark for comparison purposes if I am talking about a change? And what is the adopted benchmark for comparison? Why is that benchmark? And the question is, do we have a representative and a reliable climate model? Regardless of what global community has been led to believe, the answer is a firm no. And then there are others who should be actually participating in this debate on climate. But they are missing. For example, geology, geochemistry people, geothermal dynamics and geomagnetism, plate tectonics, Earth rotational and orbital dynamics, solar physicists. Microbial activity is also a very important concern that goes unrepresented. And we must understand that this phenomenon of climate is a result of complex and dynamic interaction between planetary and geophysical processes at the very least. And GCM started with general circulation models. They were not climate models. Current state of art, just limited scope circulation models, no more than that.
And each circulation model is to be used. No single one scores. So it's often said, for rainfall low you can use this one, for temperature use this one, for something else use a third one, but they have a common string that runs through them. They are all designed to give you a change in the temperature will change or increase in the carbon dioxide concentration. And then they came up with this idea of ensemble-based modeling, where the averages will cancel out the errors, but the only thing that remains a constant feature is the assurance that with a change or an increase in the carbon dioxide concentration, it will always show an increase in the global temperature. That won't change. So the only common string is they're all programmed to simulate a disproportionately exaggerated temperature response to increase in carbon dioxide levels. So to link what we have recently observed to carbon dioxide from fossil fuels is actually a gross trivialization of this concept of climate. I've already talked about weather forecasts and long-term projections and extremely extravagant indulgence. Those who do, they are confident because they are safe from the burden of accountability. We are all going to be long dead when it's time to verify the results that I have given you. And climate change studies, it's a joyride, quick starter. Downscaling experience, I'll relate that story. I think Dr. Maheshwaran can share those experiences with you. It's no integrity at all. There's no consistent downscaling principle or strategy. So we actually run the risk, a terrible risk, of driving humanity towards disaster by ignoring the reality, by believing in a stage-managed, a fabricated, a fake reality. So there is this concept of three-body principle which was developed by Henri Poincaré, and it was in response to a challenge posed by a king in Sweden. He wanted to see if the solar system is stable, whether it's possible for a planet actually to be ejected out of the solar system, or even a planetary collision. The questions that were asked is whether chaos exists in planetary trajectories, and if yes, is it sufficiently pronounced to cause ejection of a planet from the solar system or even cause planetary collision? And what do we see? I'm just giving you some references. We have seen chaos in planetary trajectories, and more important, chaotic obliquity has been studied here, both of Mars as well as planets in general. And we have seen that obliquity is one of the things that causes the cycle of about 100,000 years. And that explains almost about 26. Then Robert Oppenheimer, there must be no barriers to freedom of inquiry. In fact, this is where the problem is, because they do not allow a free inquiry into what they are doing. That is the problem. We don't even know the data they are giving us. How they get that, how they derive that, what are the things they do, how their model works. And this is the best of all. The optimist thinks this is the best of all possible worlds. The pessimist fears it is true. Thank you. It's going to last for about 20 to 25,000 years. So stay away from this. This is not a credible research area. For those of you who are planning your thesis, dissertations, master's study, do not entertain thoughts of working on what we have traditionally seen being dished out in the published domain, in a notch. That's the idea behind research, right? We solve problems, we try to seek a solution, but at the same time, we also try and lift ourselves up in terms of the scholarship. So you would be defending indefensible because that's a research that we have to defend. What have you got to show otherwise for the time that you spent? So there will be one more cheerleader saying we are heading towards a burnout. Sea levels were 100 meters lower about 10, 15, 12,000 years ago. And while they were 9 meters above also at some point in time, let's try and explain them. What could possibly have happened for sea levels to have actually gone up 100 meters? We are talking about the sea level rise. All right. So forget about the data. Let's cross it out. Let's say this data is humbug. It's bogus. Let's look at the historicity of what we have as recorded evidence. So the strength of my argument is not based on the esoteric analysis techniques. The strength of the argument is on the basis of the recorded evidence. Submarine feature, today people do talk about the Great Barrier Reef. They're concerned. But it was not always underwater. It came underwater only about 7,000 years ago. So what could possibly have led to that? Let's answer that. And simultaneously you can see the consistency with which this phenomenon was happening and how it affected civilizations at that time for thriving. Alexandria, seeing everything is underwater. Dwarka, water. British Isles, we are seen to be isolated landmasses. These were connected with the continent. There was a land bridge that connected that with the island, the Irish Isles. Bosphorus, it was a freshwater lake. Now it's a saline system. How do we explain that? So forget about the data. That would be actually trivializing the argument. Thank you.
Temperature from the Oceanocene to Pleistocene.
You see, I'm not an ecologist, but I do understand. Please understand, long before we started hunting lions and tigers, we've had life forms and animal forms which are extinct. Woolly mammoth, saber-toothed tiger, and there are a lot more. What happened to those? Sahara Desert was not always a desert. North American continent was not always habitable. So it was a huge landmass. So has ecology changed? Of course it has changed. And if it's going to continue to happen, yes, it's going to change. We cannot, because there is no planet, or rather no system as dynamic as Earth, a bustling city. But nobody lives there. And this happened in the 90s. So these cataclysmic changes have been happening. It's not something that's only happening because I'm driving my way to the office. No. In fact, there are studies which say that the sensitivity, or rather the proportion by which the temperature of the Earth will change, or global warming, with increase in the carbon dioxide concentration, is very high at low carbon dioxide levels. But eventually it actually becomes quite insensitive. And there is also a carbon dioxide cycle. Please understand, if we know geology, limestone, it's actually controlled by the carbon dioxide cycle. Oils, they are all limestone. So you have periods where carbon dioxide is not just sequestered by the plants, by the vegetation, also the formations. And there are times when for some strange reason it starts voluntarily giving it up. So there's a whole lot that I don't know. And will we know? I have no idea. Carbon dioxide cycles, in fact, Hobble, I skipped that. And this was something that was published in late 19th century. It's validated. He linked the carbon dioxide cycle also to the geological formation.
One more minute, sir.